just want to demonstrate Code Companion and what it's about with a LeetCode example. So this is a LeetCode easy problem. The problem is essentially given an array of numbers, to find a running sum of an array as the running sum at index I goes to the sum of all the previous numbers in the list up to index I, up to and including index I. So it's a pretty straightforward problem. There's multiple ways to do it, but the good thing about this problem and all the LeetCode problems is like there's obviously the naive or initial solution, and then there's like the most optimal or most efficient solution. So in this case, the first solution I'm going to say is, let's just say I'm starting off. Let's just say, rolling sum list, and then let's just say I go through each value in the number. And so I'll say current value equals to number IDX. And just bear with me, this is actually more of a Code Companion demo in its use case when learning and doing LeetCode problems. But I just wanted to make this as real as possible and start from here first. So now for this, let's just say we do this, right? We do a y in range 0 to IDX. And then we will just do something like this. Nums of, and then rs list dot append rs. Okay, so unless I made a silly mistake here, this should, oh, 1 second. So this would have to be the current value. So what essentially this is doing is so it's starting at the first value it's going through each value, and then it's essentially doing a second for loop where it's going to go up until the current index. So for the first case, it's going to go up until 1. For the second case, it's going to go up until 2, and then it's just going to keep track of a rolling sum, and it's going to add those values in the second, within its second for loop, and then append it to this list. So this works. We could press submit, and ideally this should pass all the test cases. So we're good. We solved this. We can move on, right? Now, the thing though is like, what you really want to do and get out of these problems, or at least one of the goals a lot of people try to accomplish when doing these problems, is they want to try to come up with the most optimal solution. So in this case, this solution right here would be n squared, right? Because you're doing essentially two for loops, so it'll be n times n minus 1, or in other words, n squared complexity. We would want to do better than that. And so one of the ways we can learn is like, okay, we could go back and think through, but what if we just thought this was the right solution? What if we thought this was the most efficient solution, right? So that's one problem, and that's a common problem because this is an easy problem. A lot of beginners will probably go through this problem, and so they might think that this is the most optimal solution when it's not, and it sort of misses out on further learning the concepts, new concepts that they otherwise did not know about. So, but the second problem is like, say there's a more optimal solution, but you can't figure it out. So like then the alternative is to probably come here and look at existing solutions that people have written, and runtime 1 millisecond, boom boom, like you pretty much get the most efficient solutions through here, or going through Stack Overflow. And those are all great, but and they serve as powerful mediums. And I just want to introduce another powerful medium that can be used for something like this. So I want to take this code, and let me just copy paste this to Code Companion. So Code Companion, essentially the way it works is it's connected to GPT-4, and it's a customized it's a customized personal programming tutor, or rather a personalized programming tutor to help you provide real-time feedback when you're writing code. Whether that's feedback on your solutions or help that you need to actually arriving at the solution. So those are the two core use cases. Built-in code editor, on the site. So now I just copy pasted the code for this from LeetCode. Although, we simply could have coded this in LeetCode and brought it here if we prefer that route, or in your own code editor if you prefer that. So let's just take this, and then the first thing I'm going to do is I'm just going to print what this would be, right? Just to make sure we run through, we sure all the syntax is good and everything works. So this is good. This prints out the right solution. It works. And just clear this and run this, right? One thing we could just do here is be like, we could just press submit. So now the difference between writing submit here and running submit here is submit here will just compare your solution to whatever test cases that were defined. So it's either binary, yes, you got it, or no, you didn't. Either test case passed or it didn't. The submit here is a lot different. The submit here is a submit as if you were submitting to like quote unquote expert programmer, but expert's probably not even the right word. Some programmer who knows quite a bit and say has more experience than you, who has solved more problems than you, and you want feedback on your code. They're obviously going to first check if it works or not, so that's good. But they're also going to provide you likely with advice, right? And they're going to provide you with, like, especially for a LeetCode problem or any sort of algorithmic problem, they're going to provide you with like efficiency advice. Like, is this the best way you could have done this? I could do this in one line. Go back. This is a new concept. Like stuff like that. So that's what this tool does, right? Other than like actually also helping you come up with solutions through your thinking, it doesn't provide you the answers, but it'll give you meaningful hints directly on your code. It also is a great way when you have a solution to actually get feedback on it and potentially learn of a new way to do a solution or think about the problem in a different way to help you learn new stuff at your own pace. So in this case, I submitted it, and let's just see what it said, right? So it said you're on the right track, and then it understands what you're trying to do. But then notice, like, I didn't actually say anything about efficiency or anything like that, right? Like, it's just, this is one of the things it's going to do because it understands it's a tutor, and this is what a good tutor will do, is not only determine if this works, but like, look, however, results in unnecessary computations and can be optimized. Notice how for each you're adding all the previous numbers from scratch. Can you think of a way to calculate the running sum using the running sum of the previous index to avoid repetitive computations? What if you only keep track of the previous running sum and just add the current value to it? Very smart approach, right? It's not going to code it for you. That's not the point. That's not even what a good tutor would do. But rather, it'll provide you with a hint, or like, oh, there's actually another potentially more simpler way to do this, and maybe you just didn't think about it. So, okay, cool, we could do that, and let's just say I want to sort of demonstrate, even before implementing the solution that GPT just suggested. Let me just comment all this out. Like, what if we try to what if I assumed of this? Like, I'm going back to, like, say a beginner's mind. Like, okay, maybe GPT is talking about like this comprehension, right? So like, what if I did something like this? Right. So like, I could actually even do this. This is a one-liner, and deceptively it seems like, oh, this is so much faster than this, but and the truth of the matter is it's actually still n squared, but it's compressed in one line. And so, is this faster? Let's just see what it says, right? The point is, I wanted to sort of prove two things. One, this is a common mistake or a common sort of belief, that maybe the lesser code might equate to like lower time complexity or something like that. But 2 is actually GPT, like it doesn't get fooled by that, right? So like, look, it says it improves your readability, but it's still equivalent to your previous time complexity. So look at this, right? So can you think of a way to eliminate the need for an inner loop? So the question here is pretty much, we want the running sum, right? So like, actual like a more optimal way here, instead of doing this, say doing this in O(n) time rather than say n squared, would be, okay, we would want to go through we would want to get the current value of the list, and then essentially what we want to do here is we would rather just actually just add the current value to the list at each step, right? So sorry, we would add the current value to the rolling sum. So we would just define a rolling sum as 0, and then go through each number, and then just add to that, and then just, which I didn't do, but now what you would do is you would just append that rolling sum at each time step in the for loop to the original list. So now you get the rolling sum, but you get this in a one pass through the for loop rather than 2 passes, or rather than an inner loop. And this is exactly what it sort of says, right? Like it gives you that hint of like, can you actually just try to use this, can you just try to use the numbers in the original for loop to keep track of the rolling sum rather than using an initial inner loop? So, okay, we tested this, it works. Let's just press submit again, right? So like, again, if I submit this here, as long as the indents are all good, if I submit this here, it should work. And this would obviously be faster, but like there's not going to be any sort of like the feedback other than your test case and stuff like this. But like this will provide this type of feedback, right? So it's like, nice work, the solution you have is correct and efficient, your function is using the previous inner sum, so on and so forth. The commented out code below uses nested loops, which has O(n) squared complexity, whereas your solution has O(n) complexity. And one other thing to be considered is error checking, right? So stuff like this is also really cool because it would actually tell you to like consider edge cases, stuff that we tend to ignore a lot of the times, like negative numbers or like decimal floats, stuff like that. So anyways, the point is I'm not going to continue with this, but I mean, it mentions that, and it also mentions code readability. This is unnecessary comments that we don't need. So, and we should probably assign this to a variable. So stuff like that it would mention, and the whole point is to like, it's really to make you write like good code, and make you understand and potentially even introduce you to new ways, new concepts, and new thinking approaches to overall help you develop like a deeper understanding of what it is that you're trying to learn. So yeah, this is just another medium that hopefully can be potentially valuable to those who either are starting off learning programming or I mean, using LeetCode to like go through problems, say, for some sort of preparation or just curiosity, or for their own homework, right? Like you could come in here, you could post your own homework and get help. The point of this is not to be like say ChatGPT to give you the direct solutions. It will never do that. It's gonna be something that's actually gonna guide you where you just need help. And you don't want to say search on Stack Overflow or one of the solutions here just to get the direct solution. You'd rather try to figure it out yourself, but maybe you want some guidance or hints to help aid your thinking, or it could be a medium to just get feedback on your existing solutions and just to see if it's actually the best way, or maybe there's another way to learn something new. So that's it.